Okay, where do I stop? Okay, so yesterday we introduced almost all the necessary knowledge for the traverse computation, including the adjustment for the departure and latitude, and also the directions. And we also showed a simple example about how we're gonna handle the situation when there's one side of the closed loop traverse is missing, or even more complicated situations. So for the first situation, the length and the direction of one side is totally missing. So we can use the departure and latitude of all the other sides to find out the departure and the latitude of the missing side, and also identify its length and direction. So that's the first situation, and we'll try to go through more examples about the missing size or the missing direction information. But first, let's go to check one example to verify the traverse computation with respect to the one side is missing. So assuming that we will work on the triangle, and we measure the side of 1 to 2 and 2 to 3, but we don't know the distance and the direction of the line 1 to 3. So that is you are given, or you only record the departure of 1 to 2, say that is -3. For the departure 2 to 3, that is 4. And for the latitude, say it's -2, and the latitude 2 to 3, say it's -1. And with that, we can quickly find out the departure of the departure of the line 1 to 3 or 3 to 1. So we have departure of 3 to 1 equal to minus the summation of the departures of the other lines. So in this case, that will be x12 plus x23. So that will be the negative value of this summation, which will give you the departure for the line 3 to 1 as -1. And for the latitude of the line 3 to 1, similarly, that will be the minus of the summation for the latitude of the other lines. So you have y12 plus y23, which will give you the value as 3. So with that, you can identify the directions of the line 3 to 1. So we have the tangent, the azimuth of the 3 to 1 as minus 1 over 3. And for the distance, that will be the square root of -1 square plus 3 square, which would be the square root of 10. So this is one simple example to demonstrate how we're gonna find out the missing side of the closed traverse. Okay, so that's the first situation. And let's go to see the second one. For the second one, if the length of one side is missing, and also the direction of another side is missing. Well, in this case, we have to determine whether we are able to find out or complete the missing information. So the figure here just shows one example about this situation. For the we are measuring a 6-side, a 5-side polygon, and the side of CD, AB, BC, CD, their distance and the directions are all measured correctly and recorded correctly in your field book. But for the line A to E, we don't know the we don't know the distance. Instead, we only record the direction. So we know the directions of the line A to E, but don't know the distance. So E is unknown, letter E is unknown. For the other side, from D to E, we record the distance, but somehow we missed the directions. We don't know what's the angle here. So in that sense, we have to use this incomplete information to identify the shape of the length that we measured. This is actually a little bit more complicated than the previous one. So we want to find out, for this situation, we want to find the distance of the line, the distance of the line A to E. And also we want to find out the direction of the line D to E. And so the to do this, we can first find out the we will only consider the polygon ABDA. So we only consider this one, and for this polygon, we just don't know the side of A to D. So we can actually find out the information of the distance of the D to A. We can find out the angle of D to A. So for the angle, we have, if we go to check the first situation, we have the tangent value of the angle is XDA divided by YDA. So this is the one from the XDA and YDA can be calculated from the departure and the latitude of the other lines A, B, B, C, and C, D. And similarly, you can find out the distance. Distance is F, which is a D, or the line D to A is the square root of XDA square plus YDA square. So with that, we can then get the information, the exact information of the line A to D, including its direction and distance. And then we can calculate the angle of DAE. So with the angle of DAE, we will be able to identify the shape of the triangle DAE. So that's the first step for the angle. Say that this one is alpha A. So alpha A will be the azimuth of AE minus the azimuth of A to D. And with that, we can then use the use the information to using this information to further identify the angle of this angle, the angle of at the point E, say the alpha E. So we will observe that sine alpha E shall equal to F divided by D times sine alpha A. This one actually is the property of any triangle. If you know the angle of two corners and their corresponding the length of their corresponding sides, then you can always form this equation. And in addition, you will be able to use the equation E equal to F times sine alpha D divided by sine alpha E to get the value of the the length for the side of A to E. Here alpha D is the angle of ADE, and it can also be calculated with another equation, D times sine alpha D divided by sine alpha A. So with this one, you can get the direction, the length of the line A to E and the direction of the line D to E. But you have to pay attention that this equation may give you multiple solutions about the directions and the angle, the distance. So let me just show you one example about why it's gonna happen. So say that we have the similar example. We have the similar example. We know the line A, B, C, D, and we know the direction. We know the direction of A to E, and we know the distance of D to E. Say that distance is D, and this distance could potentially be located at the E could potentially located at this one with the distance of D. It could also potentially located at this direction with the distance of D. So both points E and E prime satisfy the condition with the A to E with the measured angle and the D to E with the given distance. So usually for this kind of situation, you may have two solutions, two possible locations for the point E. Only when there's a special situation, say that A, B, C, D, you are still provided with the distance of the direction of A to E. Only when the distance from D to E is the perpendicular distance from the point D to the line A to E. Only at this situation, you will only have one solution, and the angle here will definitely be 90 degrees. So at this situation, you will only have one solution, and you can find out the unique location of point E. For all the other situations, it will be multiple solutions. So that's the second one about the missing one side, the length of one side and the direction of another side. And now let's go to check the third situation where we don't know the we have the two unknown chords of which are not adjacent chords. Instead, they will be a little bit separate with each other with one side or more than one side. So let me just bring out the problem. So say that we have the travel survey about the 5, say that's the 5 side length, and we measured the distance and direction of B to C and C to D. We also measured the direction of A to E, but we don't know the distance. We don't know the distance from D to E or from B to A. Instead, we know the angle is given, D to E and B to A. These are given, but we don't know the length. This one are unknown. So in this case, if these two lines if D to E does not parallel to the line B to A, then there will be only one unique solution. So you can identify the exact length of D to E and B to A. But if this is not parallel, but if D to E parallel to B to A, the situation will be different. You might have infinite number of the solutions, B, C, D, and say that these two lines are parallel to each other. Then if the A to B or A to E could be located here, it could also be located here. They all have the same distance, and the direction is always the same as what we measured. And A double prime, E double prime. So it means that we have multiple solutions, or infinite number of the solutions. So for this case, we cannot identify the exact location of A to E with this missing distance of two sides. So that's the third situation. And there will be the first one is the case we don't know the information of two. Just a moment. We don't know the information. We don't know the length of two sides. And if the length of two sides are known, for example, for the triangle, we have the line A to B. We know the directions. We know the directions of two lines. Just a moment. Let me try to. We know the direction of two lines. I'll say that we know the direction of A to C. We also know the direction of B to C. With that, we are able to identify the location of point C. So that will be the intersection of these two directions, and this is the point of C. So with that, we can then calculate the length of the side A to C and B to C. But for another situation, if we don't know the direction, but we know the length of the two sides, then the location of the intersection of the other point will not, the point C will not be unique. So we can still take the same example about the triangle. Say that we know the line of A to B, we know their directions. We also know the distance of A to C and B to C. Then it could be located at this point, but it can also be located on the other side of the line A to B. So this could be another point. So you will have the distance of BC, the distance of BC here. They have distance of AC, have distance of AC here. So this is the case, like you cannot identify whether you cannot identify the exact location of one point based on the length of two sides, but you can. It works for the case when you know the length, the direction of the two sides. So with that, I think I've finished all the topics about the traverse computation. Do you have any questions about this lecture? Okay, if no, I will jump to the next topic, which is about the calculation of the areas for the land. It's actually the follow-up topic about the traverse computation. So in the surveying, one one purpose of the surveying is to identify the boundaries of the land. The other purpose is trying to calculate what's the areas covered in those boundaries. And this is what we're going to cover in this lecture. So the land boundaries could be in the land boundaries could be in a straight line. It could also be in an irregular curved line. I see the questions in Teams. Actually, the lecture, all the topics covered in the lecture today will also be included in the midterm. So including the traverse computation and the computation for the areas. Okay. So I will just continue the lecture today. So for the boundaries of the land, it could be in a straight line. It could also be some irregular lines or the curved lines. But we need to find out the method to calculate both situations. And for the method, we can use the triangles. Consider them as the triangles to calculate the area based on the based on the combination of multiple lines. We can also use the coordinates to calculate the area of the land with the straight boundaries directly, with straight line boundaries directly. And if the boundary is irregular or could be some curve, then we should use some irregular in some approximation for those irregular boundaries. I will go through all these measures one by one in this lecture. So first, for the triangle, let's first go to review the equations to calculate the triangle. Assuming that we have the triangle A, B, C, and we know the angles of each one. We have the alpha A, we have alpha B, we have alpha C, and we also know the length of each side, B and C. And with that, you can actually also identify the vertical perpendicular distance from point A to the side of B to C. Say that this one is H. Then in this for the triangle, the value of H would be B times sine alpha C. It could also be C times sine alpha B. And for the calculation of the area, the method one could be like the area would be 1/2 of A times H. And in that sense, we have the value as 1/2 of A times B times sine alpha C, or it could be 1/2 of A times C times sine alpha B. Well, this also applies to the other sides. And if you know the parameter of the triangle, say that the parameter of the triangle is A plus B plus C, then you can apply another equation without knowing the angle of the of each side to get the value as A equal to S square root of S times S minus A, S minus B, and S minus C. And here S is the sorry, I get a wrong equation for that one. S is actually half of the parameter of the triangle. So that's the way for you to calculate the area of one triangle. And then let's go to check one triangle. Say that we have a special case. A, B, C, and the size of all the length of all the sides will be 6, and which means that the angle is 60 degree. And with the method 1, we can calculate the area as 1/2 of say this would be the A, this would be B, this would be C. So half of A times B times sine alpha C. So in this case, that will be half of 6 times 6 times sine 60 degree, which will give you the result as 9 times the square root of 3. So that's the first method. And then we can cross-verify whether the second method can give you the same result. First, we need to find out the value of S, which would be the half of the parameter. So that is 6 plus 6 plus 6, it's 9. And then the area would be the square root of S, S minus A, S minus B, and S minus C. So which will give you the result as 9 times 3 times 3 times 3. So it's also 9 square root of 3. So these two methods actually give you the same result, and it means that both of them are correct to calculate the angle, the area of the triangle. So that's the calculation by the triangle. And we can also use another method, which would be much more useful when you are dealing with the multi-side polygons. Say that we have a 5-side polygon, and we know the coordinates of each one. For the point 1, we know the departure and latitude, and we also know the information of the point 2, 3, 4, and 5, and the calculation of the area could be simply considered as the area of this polygon could be simply considered as the area covered by the line on the top. That will be the line 1 to 2 and 2 to 3 minus the area covered by the behind the line, which will be the line 3 to 4, 4 to 5, and 5 to 1. So the area is the area of this polygon would be top line, the area between the top line and the x-axis minus the area covered by the bottom line and the area between the bottom line and the x-axis. So in this case, we can quickly calculate the area covered by top line and the x-axis. So first, for the area between the line 1 to 2 and x-axis, which will be this one. That will be this region. And you can consider this region as the trapezoidal. So we can get the area as first of the top line and the x-axis with the line 1 to 2. The area is 1/2 of y1 plus y2 times x2 minus x1. And this is for the line 1 to 2 and x-axis. You can also go to check the part about the 1, 2 to 3 and the x-axis. The one is similar. So what you will observe is 1/2 of y x2 plus y3 times x2, x3 minus x2. And if we go for the part below, for the part at the bottom, you need to go through all these lines, each line one by one, calculate all these areas, and with that you can actually find out all the values. Here I changed the sign a little bit by switching x2 and x3. So you have the y3 plus y4 times x4 minus x3 plus half of y4 plus y5 x5 minus x4 plus half of the y5 plus y1 x1 minus x5. So so this is the way for us to calculate the area, and we can also consider another situation by considering the y-axis using the left, using the area covered by the left side, between the left side and the y-axis minus the line, the area covered by the line of the right side, and y-axis. So that will be the it will be the right side, right line plus y-axis. I'm sorry, I just gave you a wrong sign. The green should be the right, and the red should be left. Minus the left line plus y-axis. The calculation will be exactly the same to the previous one for the top and the bottom lines with respect to the x-axis. And so this is the basic knowledge we have. But in general, if you provide it with the coordinates of the inside polygon, then you can calculate the area with two equations. So the first one, a for the first equation, a equal to minus half of y1 x2 minus xn plus y2 x3 minus x1 plus until you reach to the yn x1 minus xm minus 1. And this one can also be applied for the by switching the sign of the x and y. So you have the value as minus half of x1 y2 minus yn plus x2 y3 minus y1 until you get to xn y1 minus ym minus 1. So so that would be the way for you to two equations for you to calculate the areas of the inside polygon, and you can actually go to check this one comes from the calculation with the x-axis. This one comes from the calculation with the y-axis. And if you add them together, put these two equations together, you will find 2a will equal to x2 y1 plus x3 y2 plus until you get a x1 yn minus x1 y2 minus x2 y3 minus xm y1. So you actually switch the index of x and y coordinates for the positive and negative components. To further simplify the this kind of equation, what you need to do is that you just need to list all the x and y coordinates. So for the point 1, you have y1 and point 2, y2, y3, and here you get a yn, and also you put another one, y1 here, and x1, x2, x3, and here you get xn, y1, x1. And now you just do the cross product. So for the for all these red lines, it means that the positive value. So you have x2 y1 plus x3 y2 plus x4 y3, and until you go to the x1 yn, and then for all the purple lines, you will have the negative sign. So that will be x1 minus x1 y2 minus x2 y3 minus x3 y4 until you get a minus xn y1. So this is the one simplest way for you to get the areas of the inside polygon. And now let me just give you a simple example to see how we can do this calculation. Assuming that we have a 5-side polygon, we know the coordinates of all the corners, and then let's go to do the check the calculation. So so we first list all the y coordinates for point 1, 2, 3, 4, 5, and 1. So for 1, that will be 300. So that will be this column, this row, 800, 1200, 1000, 400, and 300. And for x, similarly, you have 300, 400, 600, 1000, and 1200, and back to 300. And with that, we can go to check the calculation. First, we find out the positive component. So do the products for all these red arrows. So that first one will be 300 times 400 plus 800 times 600, and so on. And then you go to find out the negative components with these purple arrows. So minus 300 times 800, minus 400 times 1200, minus 600 times 1000, and so on. So with that, you can find out the value of 2a based on this calculation. It's around almost 1,040,000. And this will give you the area of the polygon, which will be half of this value. It's 520,000. So that's the way for you to calculate the area of the polygon with the coordinates. So with that, I will stop here and try to save some time for you to work on the quiz. And the quiz is actually assigned on Avenue to Learn. I will make it visible for you, and you should have 10 minutes to work on the quiz. Okay, so now it should be available for you to view on Avenue to Learn, and you can start to work on that. So for this one, the quiz, they will be graded based on the participation. So try to check the answer, find out the right answer. It's a simple calculation. So it will take does not take a long time for you to finish all the 2 questions. Okay, with that, I will stop recording the video and give you some time to work on the questions.